Hello everyone, my name is Shreyas. I hope you are doing well. Today we are going to solve the maximum ascending subarray sum problem. It's a Leetcode 1800 problem and it's a very easy problem to solve. Uh, Given that uh, there's an array of positive integer nums, return the maximum possible sum of ascending subarray in nums. A subarray is defined as a contiguous sequence of numbers in an array. A subarray uh, in this format is ascending if for all where L less than or equal to I less than R. Nums of I is less than nums of I plus 1. Note that a subarray of size 1 is ascending. Okay, I'm going to explain this problem. Suppose you consider this as an array, then subarrays are like 1, 1 comma 2, 2 comma 3, 3 comma 4, 1, 2, 3. These are all called subarrays and so on. This is just an example. Now what they are telling is we need to give them a maximum number which we are going to obtain from the subarray. Suppose if you consider this input, the output is 65. How we are getting the output as 65? Suppose see 10, 20 plus 30. And then if you see the next number, which is 5. So if we add these three number 30, 40, 50, 60, it's going to sum up to 60. And in next number, we need to check whether we need to calculate again from 5 because there is a break at this point. So we'll be calculating 5 plus 10 plus 50. That is equivalent to 50 plus 60, 65. So we need to check which is the largest among these two. 65 is the largest, so we'll be returning 65. And here in the next problem, uh, all the numbers are already in sorted order. So this array, every numbers in this array can be selected as a subarray. So it's going to be 10 plus 20 plus 30 plus 40 plus 50, that is 150. So the 150 is the answer. Uh, and for third problem, if you can see, 12 and 17 is in order. And 15 and 13 there is a break, and 10, 11, 12 they are in order. If you sum all these 10, 20, 30, 33, and if you count these two 10, 27 plus 29, this is going to be 10, 33. And you consider this as 13, 15, 17 plus 12 is 17, 27, 29. It's going to be 29. Out of these, 33 is the highest. So we are returning 33 over here. So let's move on to the algorithm, how we can solve this problem. Uh, I'm going to erase this. And if you can see over here, the minimum number of digits which can be in this subarray is 1 based on the constraints. So let's take this particular part and start solving the answer. See, we can try to solve this in two different ways. Right now, I will try to explain this in a most optimal solution where the time complexity can be big O of n. So, uh, here uh, we need to iterate from here until here. Uh, so before that, like what logic we can say is, uh, we can check whether this number is greater than the previous number. If this number is greater than the previous number, then we can consider both are in ascending order. Uh, and we can add those two, 10 plus 20. And after this one, again, if we go to this particular number, we can add these two with this one, and that's going to give 60. And again, we check whether this number is greater than this one. So here there is a break. So we are going to stop this loop and we will be taking 60. 60 is the longest. We will be considering that as the maximum sum, and we will be starting the new array where we will be starting the sum from 5. And we will be in the next iteration, we'll check whether this number is greater than this one. Yes, it's true. It's going to be 15. And next we will be checking 50 is greater than 10. Yes, it's true. So we are going to add this one and we are going to get 65. So let me move on to the program. Uh, Here I'm going to explain this as a program. Uh, let's see. Suppose this is the, I'm going to take a, this is the solution. Okay, at first, this is the function where we are going to take the, this is the function, and here we need two variables. Uh, one is used to keep track of the maximum value, that is 60 or 65. Say we can say that as maximum, and at first we can initialize that. Suppose if we have only one number, in that case we need to return that particular number, so the maximum will be that value. So let's initialize this with nums of 0, and then we need to calculate the array, that is sum of the values. We need to calculate those values. For that one we will be calculate subarray. We can take like this, and initially this also can be the first number, so we can give that as the initial number. And then so this can be solved in a time complexity of big O of n. So let's iterate from I'm going to iterate this from this position so that we can easily calculate this number is greater than this one. So I'm going to write for I in range 1. Here the index starts from 0. That is 0, 1, 2, 3, 4, 5. It's going to start from 1, and I'm going to end until the length of this array. The length of this array is 1, 2, 3, 4, 5, 6. It is 6. It's going to end until here. At first, I need to calculate. Uh, I will just check if the number is greater than the previous number. That is, if nums of I is greater than nums of I minus 1. Here, nums of I is this one, and nums of I minus 1 is this one. If nums of this one is greater than this, in that case, what we are going to do, we need to, mm, in that case, what we need to do, we need to add that into the array. Suppose we have taken this array, we'll be adding that. Calculate sub array. that will be you'll be adding that with a previous number. Uh, at this particular point, we'll be having a calculate subarray is having 10, so we'll be adding 20 to that one. That is nums of I. The I value is 1, so it's going to become 10 plus 20 in the first iteration. And next, what we can do is we need to, in each iteration, we can check whether we can store the maximum sum so that we can keep track of it. So we'll be using the Python library function max, and we are going to pass the maximum and the calculated subarray value. In this particular case, we will be getting the maximum. If suppose if this number is in the next iteration, here in the next iteration, what will happen? This will go to 30. The nums of 1 will become 2. Nums of 2 will be 30. 30 is greater than 20. 30 is greater than 20. So what we are going to do, we have calculate subarray, which is already having 30. For this one, 30, we will be adding this 30, which is nums of 2, and it's going to become 60. And we will check max of 60, max of 30, comma 60. 60 is highest, so in maximum 60 is going to get stored. In the next case, when nums of I is greater than nums of I minus 1, this case is not going, it's going to get failed. This case will be failed. So in that case, we need to handle the situation. So we will be writing the else block. And in that case, we need to make sure this calculate subarray will be taking the numbers from here. So we will be changing the value array is equals to num of I. That is this I will be pointing into this pointer. So we'll be changing that. And uh, after we change this particular value, we don't have to change here. In the next iteration, calculate subarray will be having 5. It will go to so 1, 2, 3, to go to fourth. When it go to fourth place, that is 10 is greater than 5. It's going to hold good. Subarray, calculate subarray is having 5. Then 5 will be added with 10. Uh, then 10 will be stored in calculated subarray. And again, in the next iteration, 50 is greater than 10. 50 will be 50 is greater than 10. So here, what's going to happen is 50 will be added to this one. We have 10 plus 15, that is 15. For 15, it's we will be adding 15 plus 50, that's going to be 65. And in this position, we will be having maximum which is stored at this particular point, that is 60. When we compare 60 and 65, 65 which is there in calculate subarray is highest, that is going to get stored and it's going to end of iteration. So we need to output the number 65. So the output will be stored in maximum. So the loop is done and we'll be returning the maximum. I'm going to erase this for your reference so that you can try the problem in Leetcode. Uh, this is the most optimal solution. If you can see over here, we are iterating just only one loop, and we are not using any extra array spaces.